Welcome to the Technician License course. This is contacting other hams, contact basics, band plans, making contacts, and using repeaters. I'm Pat Tice, WA0TDA, and you can reach me at my call sign Whiskey Alpha Zero Tango Delta Alpha WA0TDA at ARRL.net. Let's start with a typical telephone conversation versus a typical ham contact. In the typical telephone conversation, we start with a greeting. Hello, this is Pat. And then whoever I'm talking to identifies themselves. We exchange information, generally taking turns. We don't both talk at once. And then we have salutations, hello, goodbye, and end the conversation. Well, a typical ham radio contact, sometimes called a QSO, starts with a greeting. You identify who is participating by guess what? Using your call sign. Exchange information, generally taking turns just as you do on the telephone, and you have salutations like 73 when you want to end the conversation. Speak clearly and distinctly. Remember, the other person can't see you talking and you can't see them. Use phonetics. Whiskey Alpha Zero Tango Delta Alpha when letters like T or D might sound the same over the air. Always assume that all of your communications are public and choose your topics accordingly. Remember, somebody might be listening. Before you transmit, make sure that the frequency you use is clear and that you are authorized to use it. I like to think of this as driving a car and looking for a parking place. There may be many cars parked along the block, and when you see an open spot, you have to make sure there's not a fire hydrant there or a handicap zone or something. So you have to be sure you're able to park in that spot and you're authorized to use it. Same thing with going on the air and finding a clear frequency. Remember station identification. Here in the United States, the FCC requires us to identify our stations every 10 minutes and at the end of a series of transmissions. So, when I get on the air, technically I don't have to use my call sign for 10 whole minutes, but my advice to you is that you start right out using your call sign and the other station's call sign. For example, my call sign is WA0TDA. If I want to talk to another station, such as W1AW, my call sign comes first only when I'm calling for a clear frequency. For example, is this frequency clear? Is this frequency clear? This is WA0TDA. However, if I'm talking to station W1AW, I use that person's call sign first. W1AW, this is WA0TDA. Or 73, W1AW, this is WA0TDA signing clear. So other stations' call sign first, then my call sign. And remember the 10-minute rule. I don't have to always use the other person's call sign as long as I identify using my call sign. So during my conversation with station W1AW, I start out using my call sign, their call sign, and then every 10 minutes I just say this is WA0TDA, and then when I'm done with the entire conversation, I'm able to go and say this is WA0TDA clear. Remember too that all of our frequencies are shared. No one has a prior claim to a frequency. Schedules, nets, and pre-planned events notwithstanding, I have to observe if somebody else is using that frequency that is theirs to use, and I have no reason, even though I've planned a net and plan to meet somebody on that frequency. Now what can I do? I can ask nicely that other station, hey, I have a net coming up here scheduled on this frequency. Do you mind moving? And if they don't want to move, that's perfectly okay. I need to have a plan B, and I can move to a nearby frequency and conduct my net. It's all about being polite and remembering our radio manners. Sometimes we need to exchange signal reports. If band conditions are poor, it's important for me to let the other station know that he or she is not being heard very well, and I appreciate getting that information about my signal as well. We have to pay attention to the power level that we use when we talk on the radio too. I don't always need 100 watts or 1,000 watts or even 10 watts to talk on the radio, and the FCC does require us to avoid using excessive power. We're supposed to only use the amount of power we need for clear communications. A location, or QTH as it's sometimes called in ham radio, is where I am. And this can be either plain language, Woodbury, Minnesota, Stillwater, Minnesota, or a grid locator. My grid locator here in Woodbury is EN34, or Echo November 34. You can give a signal report using the RST system for Morse code, where R is readability 1 through 5, the signal strength is 1 through 9, and the tone of the CW signal is 1 through 9, with a buzzing tone that's kind of rough sounding being a 1, and a perfectly clear musical tone being a 9. But most of the time we're going to be talking using a handy-talkie, let's say, and if I'm using a handy-talkie, I don't need to have a RST report. I can just say, well, I'm hearing you quite well. Or if you're using the HF bands, oftentimes I'm talking into the microphone like this, connected to a HF radio. I give a readability and signal strength report. So readability is perfect, 5. Signal strength, perfect, 9. You're 5 by 9, and that would be my HF signal report. On the VHF or UHF bands, using a repeater with one of these little guys here, you're probably just going to use plain language and tell people how well you're hearing them. Oftentimes, since this is a hobby and it's a technical one, we need advice and assistance. Don't be afraid to ask for an antenna test or a check of your radio when you're talking with somebody else if you want to find out how they're hearing you, and offer to help others who want the same thing. Ham radio is largely self-regulated. Of course, here in the United States, our regulating body is the Federal Communications Commission, but we have to help each other out. So observers from ARRL may be able to offer us assistance. If we're transmitting out of band, for example, I would certainly want to know if I was transmitting inadvertently out of band. That would be an illegal activity, and it's better to have somebody from ARRL let me know, hey, you transmitted out of band, and then I can go and try to figure out what I did wrong. So we help each other out that way. Do you keep notes? Well, I like to keep notes. It's called logging contacts in amateur radio. And there are actual paper spiral-bound notebooks that we can use for that. Most people, however, use a computer. I use the logbook program at QRZ.com, and I really like that one, but there are plenty of them out there, some of them free and some of them are pay-for. One thing, though, is if you like to trade QSL cards or participate in award programs or contesting, those are the kind of activities where you will definitely want to do logging. QSL cards, by the way, are just paper cards, usually the size of a postcard, something like this. and I might trade this kind of a card if I want a memento of that contact for some reason. Well, we need to talk a little bit about different modes and radios. There are so many different choices. From these little radios like this is the kind you're probably going to be starting with as a technician class licensee, talking short distances on VHF and UHF, or longer distances using repeater systems or digital connections around the world, as a matter of fact, if you're using something like this Yaesu Wires HT. But those are different modes of operation. You may even want to get on remotehams.com and operate a station remotely. That's a possibility. Or you may want to operate the HF bands using a microphone or a Morse code key, and there is equipment to do that too. All kinds of different types of equipment. In order to keep everything straight on the band, we have band plans. A band plan is a formal plan for organizing the type of operation on a band. Think of it as kind of a guidance system, a traffic cop, if you will, of places where we can use certain frequencies for certain different types of modes of operation. It's an informal agreement in a sense, and it's not really a regulation by the FCC per se. It's intended just to keep things clear and working well on the bands. So we know that certain frequencies are calling frequencies, like 146.52 megahertz on the VHF band, and that's usually a frequency where we use FM voice. So a radio like this, I would get on 146.52, and that would be a local calling frequency. It's not usually used for repeaters, so that would be set forth in the band plan as a calling frequency. Now I want you to remember 146.52 because that question could be on your test. That's a VHF calling frequency. Anyway, could you set up a repeater or use that frequency for something other than calling? Well, I guess you could. It's not really specified that you can't, but you do need to be flexible in times of heavy band use, and it's good to keep calling frequencies free for emergencies. You can also use a calling frequency to meet somebody on the band and then say, well, okay, W1AW, this is WA0TDA. Let's move over to the repeater, and we'll use that. So that's what a calling frequency is for. Remember, somebody else might be wanting to use that calling frequency, so you should always have a plan B. Some frequencies are set forth as places that we can and cannot use phone operation or other types of modulation. There are places that we can and can't go as technician class licensees. Extra class licensees have full privileges. General and advanced have lesser frequencies. And novice and technician have the fewest number of frequencies and privileges as set forth on this band chart. Now this is not a band plan. This is what is set forth by FCC regulations. I urge you to take a look at this plan and start with the key on the upper right hand side. See where it's blue? On the upper right it says key, and that says what frequency or what modes of operation are allowed in certain parts of the bands. The bands are all on the left hand side there and in the center. Some are shown in red, some are shown in red and green, and those represent different types of modes of operation, as you can see in that key on the right hand side, with the red being RTTY and data, phone and image in green, CW or Morse code only in that kind of squiggly black and white, hash pattern. Single sideband phone only in the yellow areas. Upper sideband phone, CW, and data in the blue, and that only applies to the 60 meter band in the lower left corner of the chart. And then take a look also, let's say at the 20 meter band right in the center. Do you see it? Right in the center of that chart? 20 meters, 14 megahertz. That reminds us of the wavelength and the frequency at once there. So this is a great chart because you learn to associate the frequency, or 14 megahertz, with the wavelength, 20 meters. It's good to be able to kind of do those conversions in your head. The other thing you can take away from that 20 meter section there in the band is that you see on the right hand side those three letters EAG just to the side of that green portion. Where is the T for technician? There isn't any. That means technicians cannot use the 20 meter band. However, extras, advanced, and general class operators can. Can an extra class use single sideband phone at 14 megahertz? No, they can't, because that section is in red. And that, as we see from the key, is RTTY and data. Can they use single sideband or phone operation in the green parts? Yes, they can. So, take a look at the band plan. You can see where technician operators can operate and what modes of operation they can use. We can talk more about that later if you're interested. Now, let's make some contacts on repeaters. For repeater operation, it's going to be just the same as any other kind of operation. The very first thing that we want to do is listen. Listen to see how the regulator or the regular users operate on that repeater. Listen while you're driving someplace. Listen while you're pursuing other leisure activities. Just listen for a while and see what happens on that repeater. Gives you a good idea how to use a repeater. Of course, if we intend to use the repeater right then and there, it's important to listen to see if it's in use already, because we don't want to barge in on somebody else's conversation. To announce your presence, just say your call. So, if I go on a repeater, I'm not going to call CQ. What I'm going to do is just get right out there and say, this is WA0TDA. Anyone around? And that's good enough to make a call for any other station that I want to hear on the repeater to give me a call back. Of course, if I've got a specific station that I want to call, let's say KC0LJL. This is WRA0TDA. Are you around? So I'm calling the other station, and either they come back to me or they don't. So that's how it's done. A repeater is often used by a club or a group as a regional intercom. And it's often used for just regular run-of-the-mill conversations, getting together, passing the time of day type of thing. However, there may be nets or emergency exercises on repeaters too, and so those things can happen. Just be aware of that. You can give a signal report on a repeater, and usually this is just done in plain language. If somebody says that you are full quieting, that means that your signal is strong enough that no noise is heard, so none of that background hiss or anything. If it's scratchy, then there's occasional noise with your signal. If there's flutter, there might be multipath operation, so it might be kind of a foof, 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 foof sound to the signal. And if you're going in and out, that means occasionally your signal is copyable but mostly inaudible. We don't really need a 5x9 signal report, that RST system on repeaters. So just plain language is fine. Just tell them how you're hearing them. That'll be perfect. Now, on the HF bands, however, this is different. I'm going to be using a a standalone transceiver and a microphone like this that's wired to the transceiver. And if I get on a frequency, I'm going to listen first on that frequency, same as I do on the repeater. Just make sure that I'm listening so that I know before I use this, and I'm not going to talk over somebody else. So when I've established that the frequency sounds clear, I'm going to get on and I'm going to say, is this frequency in use? This is WA0TDA. And the reason I need to do that on the HF bands is that band conditions can change quite a bit, and I might only be hearing one side of a conversation. Somebody might actually be using that frequency, and I'm just not hearing the station that's speaking there. But if I wait for a while, I can hear the other station who's in the distance range, the skip range of that HF station, and then I can hear them. So it's a good idea. Now if I do establish that the frequency is clear, then I can call CQ. CQ, CQ, CQ. This is WA0TDA, Whiskey Alpha Zero, Tango Delta Alpha, calling CQ and standing by. So that's how I do it. I give the other station's call sign if somebody else is calling CQ. Let's say I hear W1AW calling CQ. So I decide to call them. I'm listening on the frequency. I hear them calling. They're calling CQ. So I say, WA0TDA, this is Whiskey Alpha Zero, Tango Delta Alpha, WA0TDA. And that's all I need to say. Then I let go of the push to talk button, and either they come back to me or they come back to someone else. And the use of phonetics is very important and common on the HF bands because the HF bands are not as predictable and clear as using a repeater. So just remember that. Learn your phonetics. Making contacts is fun, but we do have to take turns, and we do have to be aware of different types of operation when we're using nets, roundtables, or shared contacts. So during a net, which is a get-together of stations that are there for a common purpose. Let's say it's a weather net and people are exchanging weather information. So when I check into that net, I should know that that is let's say the regional weather net, and that net will have a net control station, or NCS, net control station, and that station is in charge of running the net. So if I want to check into that net, I wait for a pause and then I give my call sign. So I hear the net control station calling for more check-ins. This is net control station calling for check-ins. And then I get on there and I say, this is WA0TDA, or better yet, just WA0TDA, or Whiskey Alpha Zero Tango Delta Alpha. All I really need is my call sign, and then the net control station can get me logged in, and they may be taking a list of stations, so I have to be patient. And then they'll get back to me in turn, and they'll give me a call and get me checked into the net. Roundtables are a little bit different. A roundtable is kind of like a net where people get together to talk about stuff, whatever, and they just pass the conversation around the table. So it's just a round table. There is no net control station. So I just remember who checked in before me, when I checked in, and who checked in after me, and we just pass the conversation around. So it's kind of fun. There's different ways of operating though. And this takes a little bit of practice, but you'll learn how to do it. In fact, roundtables are very common, as are nets, on repeater systems. So this is something you're going to run into for sure. On simplex FM, that is to say you're using a single frequency. You're not using a repeater system at all. You're just using 146.59 or 58 or something like that, a single simplex frequency. So you talk and each user takes turns to transmit. And this is good if you're within a few miles of the other station. So you don't need to use a repeater in that case. And when would you do this? Well, let's say you're on a hidden transmitter hunt, or you're at an event, a ham fest or something, and you want to talk to other people at that event, and you're within a few miles of each other, or maybe even a shorter distance. Why tie up a repeater when you can just use a simplex frequency on your handy-talkie? And in fact, you can set the power down to maybe 1 watt, so you can save your battery when you're transmitting, and you're very close by, so simplex frequencies work great for that. Our two simplex calling frequencies here are 146.52 megahertz and on 70 centimeters 446.00 megahertz in the band plan. Let's do a little review of repeaters. Shows mountains there. Repeater located on top of a mountain would really have a good range. It's a specialized transmitter receiver interconnected by a controller. And if it's located on a mountaintop or on top of a tower, anyway, some kind of a high point, top of a high building, a skyscraper maybe, or a water tower, it can receive and simultaneously retransmit your signal on a different frequency and do it from that high location, so that it really has a nice range all the way across a multi-county area. So this dramatically extends the distance that you can talk on your handy-talkie. If I'm just using two of these to talk to each other, simplex, it might just be a mile or two. But if I use a repeater, I can talk quite a distance, and it might even be tens of miles, maybe even more. And of course, if I'm using a wires or digital connected DMR radio or Wires X, I can probably make contacts around the world with that. It's enhanced by internet connectivity. Now, how do repeaters work? Well, you have a shared antenna, you can see that in the center of this diagram, and a duplexer that separates receiver from transmitter and allows us to save a bunch of antenna work by just using one single antenna. So I don't need a separate antenna for the transmitter and a separate antenna for the receiver. So the antenna can be up on top of a water tower or something like that, and that's a great advantage to just have to put up one antenna instead of two. In duplex communication, I'm transmitting on one frequency while simultaneously listening on a different frequency. Repeaters do use duplex communications, and therefore they have two frequencies that we have to remember. The first one is the output frequency. This is the frequency that your repeater transmits on and that you're listening to. So if somebody's already talking on the repeater and you turn on your handy-talkie and it's set to that frequency, that is the output frequency of the repeater. The input frequency, once I press this transmit button, is listening, and that's going to hear my handy-talkie, hopefully, when I go to transmit. And then the repeater is just going to repeat what I say into my handy-talkie, and when I'm talking into my handy-talkie, this small signal goes out, it's received by the repeater on the input frequency, and then it's retransmitted at the same time on the output frequency, so somebody many miles away can hear me. So that's how I managed to use this little handy-talkie to talk many miles, maybe 75 miles, where I could never do that on simplex. But I need to have a repeater between the two stations. Now, we need to know certain things about a repeater. We need to know the output frequency and the frequency offset, which gives us the input frequency. This is what we need to know to set up our handy-talkie with the proper frequencies to be able to work that repeater. And if there's an access tone on that repeater, we need to know that too. Access tones are needed to prevent interference from other services messing up the repeater system. So with that information, we can set our handy-talkie settings so that we can use that repeater effectively. A repeater has an output frequency, as we said, and these are frequently identified by their output frequency when we talk about the repeater to other hams. So, for example, I might say, meet you on the 443.5 machine. So I'm using the specific frequency. Or I might say, let's go to 9.4, and that's just an abbreviation for a standard repeater channel, which is the 146.94 megahertz channel. Or the repeater might have a name. What about the NARL repeater? So here what I'm doing is I'm talking about the repeater that's referenced by the sponsoring club. So the NARL club runs this repeater. So I say, let's use the NARL repeater. And I might say, let's say I might use the SARA repeater. So that's the Stillwater Amateur Radio Association. And that's the repeater that we sponsor. So that's how we refer to it. Repeater frequency offsets vary by band, and some of these might be on your questions, and so when you study for your exam, you should try to remember these. The offset frequencies, or splits or shifts, and they're standardized within each band. So starting with the 2 meter band, it's plus or minus 600 kilohertz. That's right there in the center. The 1.25 meter band, however, is minus 1.6 megahertz. The 70 centimeter band, which is also covered by most of these common handy-talkies like the 2 meter band, that has plus or minus 5 megahertz. So especially I want you to remember 2 meter offset plus or minus 600 kilohertz and 70 centimeters plus or minus 5 megahertz. Go through your question and answers, do some practice tests, and pay attention to those, and then you'll get them right on the exam should they show up. Now, repeater access tones help prevent interference, and it also prevents accessing multiple repeaters at once. Now, you would find this out if you went, let's say, to a mountaintop or a really high location. And I tried this once from a Cessna, flying a Cessna aircraft, and just transmitting on a frequency and seeing what I could hear. Well, guess what? This was the days before a lot of access tones were out there, and in a common repeater frequency of, let's say, like 146.94 megahertz, oops, I bring up multiple repeaters because I'm located high up in the air in that small aircraft, and it's line of sight to some of these other repeater systems that I don't expect to bring up. So an access tone can prevent accessing multiple repeaters at once. You definitely don't want to do that. You want to use one repeater at a time. Also, band conditions can change depending on weather and different things, and even if you're not in a line of sight of a repeater, maybe one that's several hundred miles away, can suddenly, because of band conditions, start coming in where you are, and you don't want to cause problems on that repeater. So repeater access tones are important. There are subaudible low-frequency tones, and they must be present before the repeater transmitter will turn on. There are other types of tones too, digital ones, and these have various names depending on the equipment manufacturers. What I've heard is PL, which was a Motorola trade name for CTCSS, which is what the technical name for the common repeater tone system is. The other one that's in use more and more now is the digital one, digital code squelch. That's the one there on the bottom, and that's what we use for our Sarah repeater. And it's just a matter of setting them up in your handy talkie. It's a little bit of, well, you might have to get out that instruction book to do it, but you can do it. And then once you set it in there and save it in a memory, you don't have to remember that anymore. But you might have to remember it for your test. So let's know what DCS, or digital coded squelch, is, and CTCSS. Access tones are usually published along with the repeater frequencies. So if you go to look on the Stillwater Amateur Radio Association website, you will find that the repeater access tones are listed right there along with the frequencies. And it would be, if the tone is 123.0, that means 123.0 hertz when you're looking at one of these lists of repeater frequencies and tones. And their tones are generally programmed into the radio along with the frequency and the offset. So that tones are very common right now. There are very few repeaters without some kind of tones or digital code squelch. Repeater control is built in to any repeater system, and that includes an identification system so that we're FCC compliant if we operate a repeater. And you can choose to either have synthesized voice, so it will say what your call sign is for that repeater, or you can do it by Morse code. The FCC doesn't care. But it's the same ID requirements that you have, which is the repeater has to identify every 10 minutes and at the end of a series of transmissions. Repeaters are set up too to have timeout protection. So sometimes, you know, these little things here, we carry them around, we put them in our pockets, they go in our purses. They go on the seat beside us, and sometimes they get sat on inadvertently. And what happens then is this little push-to-talk button will be activated and we don't know it. So this thing could be transmitting if we sit on it, or if it gets jostled or something like that, and something is pushing against it, and that the transmission is going on and on and on, and it can be tying up a repeater. So repeaters have timeout protection against that. And that timeout protection protects against a continuous transmission in the event of that stuck push-to-talk switch. Or, as sometimes happens, if you get somebody who's really long-winded, the repeater will cut them off after a period of time, and it's usually 2 or 3 minutes. Now, 2 or 3 minutes is a long time to be talking. If you're talking for 2 or 3 minutes, you're talking a very long time. And I challenge you to put something into the microwave and just stand there watching the countdown timer as it works its way through 1 minute, then 2 minutes, and then up to 3 minutes. You're thinking, man, this thing is going on forever. Well, the repeater doesn't like long-winded people, and if you talk too long, the timer, which can be set by the repeater administrator, will cut you off. And in the Stillwater Club, we do have a Release to Listen award. So I do want to release my push-to-talk switch in a timely manner, or I might win the Release to Listen award. And the Release to Listen award indicates that I'm kind of a long-winded person, and it's not really a good thing. But it's a way to remind us to keep those conversations moving along. A repeater may also have a courtesy beep, so that when I stop talking and release the push-to-talk switch, it will do a beep. Not all of them have that anymore, but some of them may, and that's what they're there for. It's just to kind of alert the other station that it's time for them to start talking, that I've finished talking. Uncommon anymore is an auto patch system for phone calls, but a repeater can have them. And if a repeater does have that kind of a system, then I'm able to use the keypad on a radio to make phone calls, and this will actually connect to the telephone system. As I said, these are not as common anymore now that everybody has cell phones, but they used to be a thing. Common problems that you can run into when you're using a repeater: you might be off frequency, and this is sometimes shown by some audio distortion. Also, if the audio is getting distorted, you get a bad signal report and audio distortion and so forth. You might have a low battery. Poor location. Maybe you're down in the basement and you're not maintaining a good contact, or you're behind a hill or something like that. Just at a low location and you're not making good contact with the repeater. You might have the access tone that we talked about, or the digital code squelch off or set wrong. So that means the repeater might be coming in really well and you hear it, but you just can't seem to transmit on it. That's probably what's wrong. And the repeater might drop in and out of your receiver, so there's the squelch setting on your radio, which again is an adjustment you might have to go to the instruction book for these days, but they are all preset, but you might need to set that squelch if you run into that kind of a problem. A digital repeater system is a repeater system that's linked by the internet. It uses digital audio, so VoIP or Voice over Internet Protocol. So it's kind of similar to Skype or programs like that. It allows communication worldwide. One of them is called the Internet Linking Relay Project. There is a system of IRLP repeaters out there that are linked. Echolink is another one, and this is a free program that you can get at echolink.org. And you can use this guy here, your smartphone, to run Echolink if you have an Android or an Apple phone, iPhone. You can use either of those systems. The software is totally free. If you're using Android, you get it at the Play Store. If you have Apple, go to the iTunes Store, and then you set the Echolink application up with your call sign and your grid square, or your location, or whatever information about your name and so forth. The Echolink people will verify that you have a valid amateur radio license, which you must have to use this software. And this software does allow you to connect to actual different repeaters around the world and to other Echolink users, and therefore the signal is being transmitted out on the air, and that is why you need your FCC license to be able to do that. So you do have to have your call sign, or you cannot sign up for Echolink. You can still download it, but you can't actually use it, and you can't listen on it or anything else. So don't even bother with it until you get your license. And these days, they may even restrict downloads if you don't have a license. I don't know about that. I've had it for a long time. Okay, DMR stands for Digital Mobile Radio, which time multiplexes signals so that you can squeeze more than one signal onto a single 12.5 kilohertz repeater channel. It's a way that you can talk around the world using just a little handy-talkie. If you connect to a DMR repeater and you know the codes for the other repeaters that you want to talk to, you're in, and you can do that. DMR for Dummies is available, and you can take a look at that. It explains the different time slots and how it works. I don't know if there are going to be any questions about DMR, but it's good to know that it's out there for you. And you can get fairly inexpensive radios to run DMR. D-Star is another one. It's an ICOM system, but it's a repeater linking system and digital voice protocol. Like DMR, it's got different types of repeaters linked worldwide, and you can call user to user based on call signs. And that's limited to ICOM. Now this one I'm a little bit more familiar with. This is the Yaesu system. This happens to be a Yaesu handy-talkie that I've got right here. This is the model FT70 Delta, FT70D, very popular little radio, and it runs a system called C4FM System Fusion. The Sarah repeater is a C4FM analog repeater, and it's on 146.060 megahertz. And because the Yaesu System Fusion setup allows for more than one radio to be used, I can use the Yaesu System Fusion to talk around the world and to take advantage of that WiresX system, or I can use it just the same as a regular FM analog repeater using this old radio here. So that's why the Stillwater Club set up this type of repeater system, so there's something for everyone in there. There are some practice questions that you can follow, and I would advise going and taking practice tests as much as you can. Take as many practice tests as you can, and don't stop doing it even up to the day that you're ready to take your actual exam at the VE session. And the reason I'm saying that is because you can feel really good about the VE session and enjoy yourself with the certainty that you're going to pass because you've familiarized yourself with as many of these questions and answers as you possibly can. Thank you for listening. For the Stillwater Amateur Radio Association, this is Pat Tice, WA0TDA. You can find me at QRZ.com. Just look up my call sign, Whiskey Alpha Zero, Tango Delta Alpha. If you need to send me an email, use my call sign, Whiskey Alpha Zero, Tango Delta Alpha, at ARRL.net or at gmail.com. Thanks, and have a great day, and good luck on your exam.